Good morning, dear students. Welcome to online class of Government Secondary School Mukto. I am Anupam Mishra, TGT Science, and today we are going to discuss the first chapter of class 10. The name of the chapter is Chemical Reactions and Equation. So we are going to learn today what is chemical reaction, what is chemical equation, how to write chemical equation, how to balance chemical equation, and what are the different types of chemical reaction. So, dear students, we already know that there are many changes occurring in our day-to-day life. We observe lots of changes, and that changes can be classified into two types. One is physical change, another is chemical change. Now, what is physical change? Those change which can be reversed by physical method is called physical change. For example, if I am stretching a rubber band and again leave it, it will come to its original position. This is an example of physical change. Another example we can say, if we heat an iron rod to red hot and if we again cool it, it will be we will get the same iron rod after cooling. So it's a physical change. So physical change means change in shape, size. So there are no new substance is formed. That is called physical change. Whereas when we say chemical change, a new substance is formed and this change is irreversible. For example, if we burn a paper, we will get ash, and we cannot get back paper from the ash. Similarly, if a milk is turned into curd, we cannot get milk again from the curd. These are example of chemical change. Chemical change means a new substance is formed there. So we observe lots of changes around us. For example, when we are eating food, the food is digested. The food we ate is digested. Now the we cannot get that food back again. It is an example of chemical change. So whenever a chemical change is occurring, we can say that to occur that change, some kind of chemical reaction has undergone there. So now we have to know what is chemical reaction. So we have understood what is chemical change, and we have understood that for occurring this chemical change, chemical reaction is responsible. Now we have to know the definition of chemical reaction. So we can define chemical reaction like it is a process in which one or more substance formed new substance. So from one or more substance we get new substances. This is called chemical reaction, and it cannot be reversed by physical method like magnetism, filtration, centrifugation, distillation, evaporation. But these are the few physical method of separating things. By doing this, we cannot get back the original substance. Then that type of reaction is called chemical reaction. Now, how we will come to know, or how we can determine that some chemical reaction has undergone here? So by observing few changes, we can say that chemical reaction has undergone here. For example, if we see change in state, change in color, change in temperature, evolution of gas, these are the indicators which indicates that some kind of chemical reaction has occurred here. After that, we are going to learn about some chemical reactions happens in our daily life. So few examples are given here. For example, digestion of food, I have just talked about it. Respiration, rusting of iron, formation of curd, photosynthesis, and all that. There are many such examples which we observe in our daily life that chemical reaction is undergoing there. So whenever a chemical reaction is occurring, uh, that chemical reaction can be represented with the help of an equation. That is, we call it chemical equation. So we can define chemical equation as a chemical reaction can be represented by chemical equation. It involves symbol of substance of reactants and product with mention of physical state. So writing the chemical equation with the help of symbol is called chemical equation. For example, here magnesium ribbon when burnt in air gives magnesium oxide. So we can see here the symbol of magnesium. Suppose we can write symbol of magnesium as Mg. Mg, magnesium. Plus when it is bound in oxygen means we can write O2. So this is going to give magnesium oxide, MgO, magnesium oxide. So this is a chemical equation. So when we are writing this in a symbol form, we call it chemical equation. But it can be written in words also, like magnesium plus oxygen, it's going to form magnesium oxide. Now this, when we write in words, we call it words equation, and when we are writing it in with the help of a symbol, we call it chemical equation. So chemical equation can be written in words also and with the help of symbol also. Here we can learn that the substance which are in left hand side of this arrow, we call it reactant, and the substance, the product which is formed, which is written on the right hand side with the arrowhead in between, that is called product. So when we write a chemical equation, we get two things, that is, one is reactant and one is product. So we can define reactant who take part in chemical reaction. So these reactants are the first which take part in chemical reaction, and product means after reaction the substance form is called product. We have just seen the example. So we have came to know what is chemical equation now. And one more thing here to know is aqueous solution. What is aqueous solution? Here aqueous, the word is coming. Aqueous means whenever a chemical, a solute particle is dissolved in water, we call it aqueous solution. So it can be defined as it is a solution in which solvent is water. So after that, we will learn about how to balance chemical equation. So for balancing chemical equation, first what we have to do is, so suppose we have taken one example here, how to balance a chemical equation. Here we have taken iron, we are writing the symbol Fe plus H2O gives Fe3O4 plus H2. Now it is an unbalanced chemical equation. Now we are going to balance the chemical equation. So why we need to balance the chemical equation, that too also we have to know. We need to balance the chemical equation because we have learned in class 9 the law of conservation of mass. The law of conservation of mass states that the mass cannot be created nor be destroyed. That means the total mass in the reactant side should be equal to the mass in the product side. Therefore, we need to balance the chemical equation. Now we can see how we are going to balance the chemical equation. We have written here uh, iron plus water, uh, it's give iron oxide plus hydrogen. So here first what we have to do in the first step, that we are going to make boxes around this substance, uh, because we, while balancing this, the main substance should not change. So whenever we are balancing it, we have to see that we cannot make change in this inside this box, because if we alter here, a new substance is going to form. So we have to just balance this equation. We cannot change the substance. Therefore we are making brackets around it, so that there will be no confusion. Now in second step, what we can do here is, we are going to count the number of atoms in the uh, reactant side and number of atoms in the product side. For example, here we are getting three element. We can see here, suppose these are the elements, reactants and product. Now in the reactant side we have iron. Here no react product, we have three elements, hydrogen and oxygen. Now we are going to see how much atoms is present in the reactant side. For example, iron here only one, we can see one here, so we can write one. In the product side it's 3, so we will write 3. And next, hydrogen in the reactant side it is 2, in the product side it is 2. Oxygen, we can see here in the reactant side it is 1, and in the product side it is 4. So first we are going to take the element which has the highest number of atom, maybe either in the reactant or product side. So we can see here oxygen is the highest, has the highest number of atom, that is 4. So first we are going to balance this 4. Now how we are going to balance here? We can see here 4, so we cannot write 4 here. So now we have to write the number outside the box. So if we want to make 4, we have to multiply this with 4. So we will write 4 in front of this, like this, 4. So here we have written 4. Now this 4, but here see, when we are balancing the oxygen, now the hydrogen is changing. It was already 2, 4, we are writing outside, so it will multiply 4 to the 8, but here it is only 2. So now we have to balance this one. So we are going to write 4 here. So 4 to the 8, 4 to the 8. Now oxygen and hydrogen is balanced. Now we have to see the next one, that is iron. Now iron is 3 here, it's 1 here. So if you multiply 3 here, now the equation gets balanced. So now we can write the balanced chemical equation as 3Fe plus 4H2O, it's iron oxide or ferric oxide, we can say, plus 4H2. Now this is a balanced chemical equation. So the main step here, what we have to do while balancing a chemical equation is, we have to count the number of atoms in reactant side and product side. And first we are going to take the atom which have highest number of atom. First we are going to take the element which have highest number of atom, and after that we will balance that. And if some changes is occurring in the another element because of balancing that, then we are going to take balance that second element, after that third one, like that we can balance the chemical equation. So this is the process or steps of balancing the chemical equation. Now after that, now we are going to study types of chemical reaction. What are the different types of chemical reaction? So to study different types of chemical reaction, we are going to study 5 types of chemical reaction. The first one is combination reaction. Now the name itself suggests combination reaction. Combination means coming together or joining. So when two or more elements join together to form a single product, we call it combination reaction. Example here, it is given A plus B, it's going to give AB. That is burning of carbon in presence of oxygen gives carbon dioxide. That is formation of water, H2 plus O2, it's giving H2O, that is the water. So these are example of combination reaction. So it's very easy. We can say that combination reaction means whenever two or more reactants combine to form a product is called combination reaction. After that, we will see the second type we are going to see is decomposition reaction. Now, what is decomposition reaction? It is just a reverse of the first one, what we have learned, the combination reaction. Decomposition reaction means in this reaction, a compound splits into two or more substances is called decomposition reaction. Here, one compound is going to break into two or more substances. That is called decomposition. Decomposition means breaking down. So here we come to know that when one substance is going to break into two or more new substance, that is called decomposition reaction. Example is shown here. Just A, it breaks into B plus C. That is called decomposition reaction. Now this decomposition reaction is of 3 types: thermal decomposition, electrolytic decomposition, and photolysis decomposition. This decomposition reaction is very important with viewpoint of your examination. Most of the time questions are coming from this portion, so we have to know now learn all these 3 types of decomposition. We are going to learn and see one by one. First, we are going to see photolysis decomposition. When decomposition is carried out in presence of sunlight, means if any decomposition reaction is occurring in presence of sunlight, if sunlight is needed for that decomposition reaction, we will call it photolysis decomposition. Example, we can see here silver chloride in the presence of sunlight breaks into silver and chloride. This reaction is used in black and white photography. After that, the next one we are going to learn about is thermal decomposition. The thermal word itself suggests that heat is required here. So when decomposition is carried out by heating, then we call it thermal decomposition. Example, we can see calcium carbonate, here heat, it's break into calcium oxide and carbon dioxide. So this is an example of thermal decomposition. And the last one, that is electrolytic decomposition. When decomposition is carried out by passing electricity, that is called electrolytic decomposition. So decomposition reaction is of 3 types: photolysis decomposition, thermal decomposition, and electrolytic decomposition. I am once again saying that for examination this point is very important. After that, next we are going to learn the third type of chemical reaction, that is displacement reaction. Now displacement means what? Removing one. Is called displacement. That means one element is going to displace the other from its position. Then we call it displacement reaction. The reaction in which one more reactive element displaces less reactive element from its solution. When more reactive element displaces the less reactive element, we call it displacement reaction. For example, here we can see we have taken iron and the copper sulfate solution we have taken, and when these two are going to react, this copper will be displaced by the iron here. because iron is more reactive than copper. So the new compound substance formed here is iron sulfate and copper is out. So this is called displacement reaction. Here example, with the help of a diagram we can see we have taken some nails and this copper sulfate solution that is blue in color. When we put this nail inside this solution, this blue color will fade away and it will turn into a light green color, and it indicates that a reaction has undergone here. And since copper has been given out and one new substance iron sulfate is formed and copper has been displaced from its position, that's why we call it displacement reaction. After that, we are going to see the fourth type of reaction, that is the double displacement reaction. Now what is double displacement reaction? A reaction is in which new compounds are formed by mutual exchange of ion between two compounds. Here mutual exchange is occurring. Example we can see here, this sodium sulfate we have taken and barium chloride. When these two react, now this sodium here has been displaced by barium and this sodium has taken the place of barium here. So both are exchanging its position. Now barium is taking the position of sodium and sodium is taking the position of barium. So double displacement. It's both are displacing each other. So such type of reaction is called double displacement reaction. Here one new term, that is precipitate. Sometimes what is precipitate reaction or what is precipitate can be asked. Precipitate means when when in a reaction some insoluble substance is formed, that is deposits, some insoluble solid deposits we find, and then in that kind of reaction is called precipitate reaction, or that is called precipitate. It is an insoluble solute that emerges from a liquid solution. So in a reaction when some insoluble solids is formed, that then we call it precipitate. So after that we are going to see the fifth type of reaction, that is oxidation and reduction reaction. Now oxidation, what is oxidation? The addition of oxygen to substance, the removal of hydrogen from a substance. So either adding of oxygen or removing of hydrogen is called oxidation. And reduction means the addition of hydrogen to a substance and the removal of oxygen from a substance. Here we can see here copper plus oxygen, copper oxide. So this is an example of oxidation reaction. Here we can see copper oxide plus hydrogen, it's giving copper plus water. Here both oxidation and reduction is occurring. Here copper is reducing, copper oxide is reducing to copper, whereas hydrogen is oxidizing to water here. So we can see here both oxidation and reduction is occurring in this reaction, and such type of reaction where both oxidation and reduction reaction is occurring, we call it redox reaction. After that we can see here the effect of some oxidation in daily life. So corrosion. What is corrosion? When a metal is exposed to substance such as moisture, air, water, acid, etc. for some time, a layer of oxide is formed which weakens the metal, hence metal said to be corroded. So corroded means actually it's a weakening of the metal. It's a example is rusting of iron. We can see when iron is left exposed outside, we can see the brownish substance deposit over that is the rusting of iron. That means the layer of the iron is they are weakening because of the reaction of iron with the moisture and air. Similarly we can see black coating over silver and green coating over copper. So this is called corrosion, and it is the effect of oxidation we see in our daily life. After that, rancidity. What is rancidity? The oxidation of fats and oil when exposed to air is known as rancidity. When fats and oil is oxidized, then it is known as rancidity. It's lead to bad smell and bad taste of the food. That means it's rotten the food. We can say that the food becomes not eatable, uneatable here. And we can see that we can find the chips packet in the market. Some air is filled inside that air is nitrogen gas. Why it is filled? To prevent this rancidity, so that the nitrogen gas, it prevents oxygen gas directly coming in contact with the chips. So we use this technique to preserve this one. So nitrogen gas is used in the chips packet to prevent this rancidity. It spoils our food. After that, now chemical reaction also classify on the basis of temperature. So on the basis of temperature, these reactions can be classified into two types. One is exothermic reaction and another one is endothermic reaction. Reaction in which heat is released along with formation of product is called exothermic reaction. The reaction in which heat is given out is called exothermic reaction. Example here, burning of methane with oxygen. We can see carbon dioxide and water plus heat is given out. So it is an example of exothermic reaction. Heat is given out here. Endothermic reaction, the reaction in which requires energy in the form of heat, light and electricity is called endothermic reaction. Here energy is absorbed. So mostly in small classes we have learned that if energy in the form of heat is absorbed, that is called endothermic reaction. But here we can say that it's require energy in any form, that is heat, light and electricity, that is called endothermic reaction. So that's all from this chapter. Thank you for watching and hope it will be benefited for you all. Thank you.